Good morning. Today I would like to discuss the concepts of probability in the subject of computer-oriented statistical methods. So before going to the concepts of computer probability concepts, just we would search the definitions of statistics. Before going to this, we will just see the definitions of fundamentals of statistics. Let us see the definition of statistics in 4 steps. Statistics means collection, classification, analysis, and presentation of numerical data. Now let us see the 4 concepts of statistics. We all of you know data means the information we gather to give a solution of a particular problem is called data. So now we are going to define the definition of statistics in 4 steps. The first one is collection. So the first thing is we are going to collecting the data. So collection of data is of 2 types actually. So the 2 types are primary data and secondary data. Let us go with the concept of primary data. So whenever we are going to do some project work, the person is collecting the data for the first time, that is what we call it as a primary data. When coming to the concept of secondary data, so it means that before you, someone already collected the data, some analysis is already find out. So as a second person, now you are going to collect the data. So this secondary data is available in all public and government sectors and private organizations also. Now let us see the concept of classification. Classification means arranging the data into groups or classes according to their common characteristics. Classification means we are arranging the data into groups or classes according to their common characteristics. So now let us see the example of a classification. Suppose we are going to define the concept of a population. Population means the group of individuals, we call it as a population. So now let us see the population means the group of individuals, we call it as a population. A small portion of this population we call it as a sample. So now in our day-to-day life, to access the quality of bag of rice, we examine only a portion of it. The portion selected from the bag is called sample. The whole quantity of rice we call it as a population. So now we are defining classification means arranging the data into groups or classes according to their common characteristics. Now this population we are going to define into 2 characteristics, that is male population and female population. Now let us going to divide this male population into educated male and uneducated. Educated and uneducated. In the same way, the female also we are going to divide this category into educated and uneducated. Again, in this male educated, we are going to define it as employed and unemployed. Here also unemployed also, it means that uneducated also we are having the category of people of employed people and unemployed people. Here female educated also we have an employed people and unemployed peoples, and female uneducated also we are having employed people and as well as an unemployed peoples. So what happened here means we are arranging the data into groups or classes according to their common characteristics. This is what we call it as a classification. Now let us see the third step, analysis. So it is depends upon the problem. We are going to define analysis based upon the problem. We are going to finding out whether you are applying the straight line or we are applying quadratic equation. So you are going to apply the, you would like to check whether the given data is right or wrong. We have to apply the concepts of testing of hypothesis. So these all the process we call it as an analysis. So based on the concepts of analysis, based on this calculation, we are going to finding the predicted values. We are going to estimate future profits. Suppose the person is started business from 2020 to 24. So he would like to stop his business. So in this way, so we are going to estimate if you would like to continue his business at the year 2020, is a person is going to get profit or loss. So by using having with the correct proper data, we are going to make an analysis and we can get with the conclusions also. So now at last, the last step is what? The presentation of numerical data. Now at last, our 3 steps are completed. That is what? Collection, classification, analysis. At last, we are going to conclude the presentation of numerical data. So this presentation of numerical data, it may be in terms of tabular forms. So tabular forms means we all of you know that it is in terms of the data we are going to represent in terms of rows as well as columns. So not only that, we are going to represent the data in terms of graphical representation like histograms, pictograms, frequency, polygons, percentage diagrams, bar diagrams. So everything we can able to calculate. So now based on the concept of statistics, we are going to define collection, classification, analysis and presentation of data. So by using all these concepts, so now let us see the concepts of probability. So before going to the concept of the probability, so we are doing some experiment to make some conclusion. So what is experiment here? We are concluding that experiment is a means of getting an answer to the given problem. Now let us see the definition of a random experiment. So before that we discussed experiment is the means of getting an answer to the given problem. This is what, for example, if you are trying something, so this is what we call it as an experiment. Either the work it may be a success or failure. So experiment is the means of getting an answer to the given problem. Now, so in each trial means an experiment again. Trial means an experiment which we have to conduct is called a trial. So now, if in each trial of an experiment conducted under identical conditions, the outcome is not unique. It means that either it may be success or failure. But maybe any one of the possible outcomes, then such an experiment is called a random experiment. So now, for example, if you are tossing a coin, so we all of you know when tossing a coin we will get the two outcomes. That two outcomes are head and tail. So this is what we call it as an experiment. Now let us see the next definition. Outcome. The result of a random experiment will be called an outcome. So now let us take an example. When you are throwing a die, so we are having 6 outcomes. The 6 outcomes are from 1 to 6. So this is what we call it as an outcome. So now let us see. Trial means, that is before we discussed an experiment which we have to conduct. So now events are the number of possible outcomes, we call it as an event. So if it is repeatedly or not, we are counting out the number of outcomes. Now let us see the next definition. Exhaustive events. So exhaustive events, or that is what we call it as the total number of possible outcomes. This is also we call it as sample space. Sample space means the set of all possible outcomes. This is what we call it as a sample space as well as exhaustive events. So if you are throwing a die, we are getting the 6 outcomes. This is what we call it as an exhaustive events are from 1 to 6. Now let us see favorable events. So favorable events means the number of cases favorable to an event, which is favorable to an event in a trial is a number of outcomes which is entail the happening of the condition. So here what does it means? We know that when you are throwing a die, we will get 6 outcomes. So if you are throwing 2 dice alternatively, the total number of outcomes are 36. So now what is the given condition which is favorable to the outcome? This is what we call it as, it means the event is going to be favorable. So now let us take an example. Throwing of 2 dice, the number of favorable cases of getting the sum 7. We all of you know that when throwing 2 dice, we are having the number of outcomes are 36. So how the outcomes of 36 we will get? Like 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. Like that we have to start with the element 2 1 2 2 6, 3 1 2 3 6, 4 1 2 4 6, again from 5 1 to 5 6, like that 6 1 to 6 6. So it means that we are having the total number of outcomes are 36. So as per this problem, what you are going to define? Favorable event. So what is favorable? To getting the sum of 5. So how many favorable events we are having? It means they are discussing about you are throwing 2 dice. So it means that when you are throwing first die, your first outcome it will be 1. When you are throwing second die, the second outcome it will be 4. So 1 plus 4. The total number of cases are 5. So in the same way, when you are adding out of all 36, when 2 events are adding, you are going to get the sum is equals to 5. So now it will be 1 4, 4 1, 2 3, 3 2. So all these you are call it as the favorable events. Now let us see the next definition, mutually exclusive events. So mutually exclusive events means the events are said to be mutually exclusive are incompatible if the happening of any one of them precludes the happening of all others. Now let us see. So in order to explain this concept, let us go with a small example. Suppose we are having with an sample space of 6 events. So the sample space is equals to 1, 2, 3, 4, 5, 6. Now we are having with the element of probability of happening of an event A is equals to 1, 3, 5. Now let us see the probability of happening of an event B is 2, 4, 6. So if you are going to discuss about the concept of A intersection B. So what is the common event of these two elements? Intersection AB, the common element in the two sets. So what is the common elements? Actually these two sets are different. It precludes the happening of an one event precludes the happening of the other event. So there is no common element. This we are going to define it as 0. Instead of this we are going to write it as pi. So this is what we call it as no two events can happen simultaneously. So this is what we call it as mutually exclusive events. Now let us go with the next definition, equally likely events. So the definition of equally likely events is events are said to be equally likely. It means that each and every element it has an equal chance to enter into the trial. Suppose I would like to give first rank in the class. In the class consists of 64 members. Without conducting an exam, I would like to give first rank. So it means that each and every person it has an equal chance to get first rank. So this is what we call it as equally likely events. Now let us see the definition. The outcomes of the trial are said to be equally likely if taking into the consideration all the relevant evidences. It means that each and every event it has an equal chance to enter into the sample space. This is what we call it as equally likely events. Now let us see the example in throwing an unbiased die. It means unbiased means without partiality we are throwing a die. So throwing an unbiased die, all the 6 faces are equally likely to come. It means the probability of getting 1 is having the probability of getting 2. This is what we call it as an equally likely events. Now let us go with the next concept, definition of independent events. Events are said to be independent. It means that if the happening of an event in the first trial, it is not affected by the happening of an event in the second trial. So, for example, we are going with the same class is consists of 64 members. Suppose you would like to the probability of attend in the class the probability of one student attend in the class if it depends upon some other person. So it means that you are a dependent event. Today if you would like to attend the class, if it does not depend upon any other person, then you are an independent event. So now the same thing here we are going to define. This is what we call it as independent events. It means that events are said to be independent. It means that if the happening of an event in the first trial is not affected by the happening of an event in the second trial, this is what we call it as an independent events. Now let us see the example of independent events. If you are tossing an unbiased coin, so if tossing a coin, we know that we have two outcomes that are head or tail, right? So the event of getting a head in the first toss is independent of getting head in the second toss. It means that these are independent events. Now let us see the definition of sample space. This is what we discussed before with the name of exhaustive elements. So it means sample space means the set of all possible outcomes, we call it as a sample space. So now let us see the definition of a probability. Now suppose, so before going to the definition, I will give you a small example. So now find the probability of getting today is a rainy day. What is the probability of getting today is a rainy day? We are having only two outcomes, whether the day it should be a rainy day or the day it should be a dry day. So how many outcomes we have? Only two outcomes. They are asking about only what is the probability of getting today is a rainy day. So what is favorable case? If it is a dry day, so the favorable element is only 1. So we are going to define the probability is equals to 1 by 2. So in the 2020 corona situation, we are going to define the probability of getting corona for a male person. So it means that we are having only two cases. Either the person is getting corona positive or negative. What is favorable case? If it is going to get a positive, it will be only 1 by 2 of having the chance. So now the same thing we are going to define the definition of a probability. So now if the trial results n outcomes, it means that we are going to define a sample space. This is what we call it as exclusive, mutually exclusive or equally likely outcomes. So out of n, we are going to discuss about favorable to the occurrence of an event. So this is what we are going to define. P of E is equals to favorable number of cases by total number of cases. We are going to define it as P of E is equals to 1 by 2. Now let us go with the definition of axioms of probability. We have three axioms of probability main. Let us see the first axiom 1. The probability of an event is real number is greater than or equals to 0. Saying in simply, we are going to define axiom 1 is P of A is greater than or equals to 0. The axiom 1 we are going to define P of A is greater than or equals to 0. So it means whenever the probability is equals to 0, the event is an impossible event. Now let us see an axiom 2. The probability that at least one of the possible outcomes of a process, it will be occur to 1. If P of E is equals to 1, it means the event it should be a sure event, or sometimes you may call it as a certain event. If P of E is equals to 1, the event is a sure event. If P of E is equals to 0, the event is an impossible event. And we know that the probability lies between 0 and 1. The same two things we are going to conclude in axiom 1 and axiom 2. So the axiom 1 is what? P of A is greater than or equals to 0. And axiom 2 is what? The sum of all the probabilities is equals to 1. Now let us see the axiom 3 is if two events A and B are mutually exclusive, then the probability of either A or B occurring is the probability of A occurring plus the probability of B occurring. So it means that in the notation how to define P of A union B, either occurs of A or occurs of B, we are going to define it as P of A union B is equals to P of A plus P of B. So the first axiom is what in notation? P of A greater than or equals to 0. The second axiom is the sum of all probabilities is equals to 1. The third axiom is P of A union B is equals to P of A plus P of B. These three are the axioms of the probability. Now let us see the basic problems in the probability. The first one is, we all of you know that our pack of cards is 52, and in our 52 cards we have diamonds, hearts, spades, clubs that are 13 each, and we have Ace, King, Queen, Jack are 4 each. So we all of you know very well. So now let us see the question. Find the probability of getting a number card when a card is drawn from a pack of 52 cards. We all of you know we have total cards are 52. The total number of ways of selecting one card out of 52 cards is 52 C1 now. So the first thing, in order to finding out the probability of the given problem, the first thing we are going to discuss about the total number of cases. This is what we call it as n. So n is here the total number of cards are 52. The total number of ways of selecting 52 cards, one card out of 52 is, this is what we call it as 52 C1. This is what we call it as 52. Now let us see, out of 52 cards, getting a numbered card getting a number chord. We all of you know the chord number starts from R's. So we are not having A1. So what are the number chords? It means that we are going to define about the favorable number of cases. So favorable number of getting, this is what we are going to define it as a numbered chord. We are going to define M is what? Numbered chord. So how many number chords we have? 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let us see how many numbers we are having. 3, 3, 6 plus 3, 9 chords. It means that M is not 9. It means that each suit is having again 9 chords. How many suits we are having? We are having total suits is 4 suits. Total suits are 4. So what are they? Diamonds, hearts, spades, clubs. That we all of you know very well. So out of 4 suits we are having number chords are 9. So now the thing is we are going to define about M is equals to 4 into 9. It means that each and every suit we are having 9 chords. Out of 4 suit, 4 nines are 36. So this is what we call it as 4 nines or 36 are favorable cases. So now we are going to define about the probability is what? P of E is equals to, just we discussed about P of E is equals to favorable number of cases by total number of cases. It means that the favorable number of cases are 36, the total number of cases are 52. We are going to finding out the solution. P of E is equals to 36 by 52 is 0.69. So this is what the solution of the given problem. Now let us see the next problem. What is the probability of getting a sum of 7 when 2 dice are thrown? So now we discussed about the first thing is we are going to defining about total number of outcomes. So how many total number of outcomes? They are completed. They are discussing about 2 dice are thrown. If 2 dice are thrown, we are having n is equals to 36. That n is equals to 36. We are going to write it as the events of 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. In the same way, let us going to start with the element 2. So here we are going to defining about 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. Now let us start with the element of 3. So it will be 3 1, 3 2, 3 3, 3 4, 3 5, 3 6. Now let us start with the element of 4. The elements are 4 1, 4 2, 4 3, 4 4, 4 5, 4 6. Let us start with the element of 5. The outcomes are 5 1, 5 2, 5 3, 5 4, 5 5, 5 6. So we are having for one die it is having 6 outcomes. So it will be start with 6 1 also. So it will be 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. So these are completely each is having 6 sets. So it will be n is equals to 36 outcomes. When 2 dice are thrown, we have the total outcomes are n is equals to 36. Now let us see the favorable cases. Here the favorable number of cases. What is the probability of getting a sum of 7? So now let us see the favorable cases of getting the sum 7. If you add the element of in the first case 1 6, 1 plus 6 the sum is equals to 7. So in the first event, when the event is first throwing first die, the event is 1, we are having only one condition. Now let us see in what case the probability of getting the sum is equals to 7 when you are having with the condition of 2 5. 2 plus 5 is equals to 7, and in the third outcome we are having with 3 4, you will get 7, and in the case of 4 starting with the 4, we have with 4 3, and starting with the element of 5 it will be 5 2, and starting with the element of 6 1. So out of these 36, in all the 6 cases we are having the favorable number of cases of getting the sum is equals to 7. So how many cases we are having? Totally it's 6 cases. So now what you are going to define here? P of E is equals to favorable number of cases by total number of cases. So what are favorable number of cases here? 6 cases you are having the probability of getting the sum is 7 out of 36 cases. So 6 by 36 is 1 by 6. So we have the probability is 0.16. Now let us see the next problem. Find the probability that the leap year has 53 Sundays. So before solving this problem, we all of you know that the ordinary year has having 365 days and the leap year is having 366 days. Right? So it means that 52 weeks means it is having with the completion of how many? 52, each week is having 7 days. So 52 sevens are 364. Right? So now the leap year is having 366 days. So now what is our given question? Find the probability that the leap year has 52 Sundays. It means it is the completion of how many weeks now here? Completion of. So what is the completion of? The leap year is the completion of how many weeks? 52 weeks. So it means that 52 week means how many days? Now we are discussing about 364 days. So we have left with how many days? 2 days. That 2 days we are going to define the remaining 2 days. It will be what is having with the combination. The remaining days are. What are the remaining combination we are having? Either it may having with Sunday, Monday, and the other combination it will be Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, and we are having with Thursday, Friday, Friday, and Saturday. So sorry, we are having with one more condition, Friday, Saturday, and we are having with Saturday and Sunday. Now let us see how many number of cases we are having. 3, 3, 6, 7. Okay. So now these are the favorable number of outcomes. So out of these we are going to finding out what are the two alternatives having with Sundays. We are having here Sunday, Monday, or whether we are having with Saturday, Sunday. So in these cases, when you are going to define about it is a completion of 52 days. So probability of getting of 52 days, it will be probability of getting 52 days is equals to P of E is equals to favorable number of cases by total number of cases. Now the favorable elements are only 2 out of 7. So it will be 2 by 7. But the thing is here we are going to finding out that the leap year is having 53 Sundays. We know that the sum of all the probabilities is equals to 1. So it means that what happens here? Probability of 52 days plus probability of 53 days, the sum of all these probabilities is equals to 1. So this is of by axiom 2. Okay. So now we finding out the probability of, this is what we are having. We got it as 2 by 7 plus probability of 53 is equals to 1. So from this, what is the probability of 53? 1 minus 2 by 7. So this is equals to 5 by 7. So what is 5 by 7 now? The probability of getting the leap year is having 53 Sundays. So now the required probability is 5 by 7. Now let us see the next question. A box contains 4 red, 5 white, 8 black and 3 yellow balls. What is the probability of getting a red or yellow ball at random in a single draw of one ball? Now let us see here. Here we are having the total number of cases is the total number of balls here. That is what? 4 red, 5 white, 8 black and 3 yellow. Here the total number of balls are 20 balls. Now let us see what is the probability of getting a red ball. P of A is equals to the red ball is how many balls we are having? Red is of 4, P of A is 4 and P of B is equals to the probability of getting what? Yellow ball. So yellow is having how many? Here it is 3. So now you are going to define it as P of E is equals to favorable number of cases by total number of cases. So this is what? P of E is equals to 4 plus 3 out of number of balls is 20. So it is what? Here we are going to define red or yellow or indicates plus. So we are going to define it as 7 by 20. So this is equals to 0.35 is the required probability for the given problem.